All right, so we spent a lot of time the last couple days looking at central angles and arcs and some relationships with tangent lines and stuff like that. Now we're going to look at a very specific relationship between the angles and the arcs, and these are called inscribed angles, okay? These types of angles. Now, we should already recall central angles. The recall part is right here. Okay, this is what we should already know. The central angle, the measure of the central angle, that's when the angle is at the center point. Okay, the vertex of the angle is at the center point. That would be angle X right here. That angle, that central angle, is equal to the intercepted arc. So see how this arc is 80? Then this angle X would also equal 80 degrees. So if the arc measures 80, the angle measures 80. That's only if it's a central angle. Now, we're going to look at what's called inscribed angles. An inscribed angle is an angle with its vertex on the circle. So right here, angle X. See how the vertex is where the 2 points come together. The vertex is on the circle right here. B is the vertex. B is the vertex. The vertex of angle X is on the circle. It's created by two chords. So it's created by BA, and it's created by BC. That's how an inscribed angle is created. I want to be very clear here. All right? So it's A, B, C. Okay, it's angle ABC. Angle ABC is the inscribed angle. They're calling it X. Okay? Now, because vertex B goes to A and it also goes to C, that makes AC the intercepted arc. Okay? AC is the intercepted arc. Go like this. Whatever arc is right there, okay, whatever arc's at your fingertips, that is the intercepted arc. So if 100 is the intercepted arc, then the inscribed angle is 1/2 of that. So X equals 50. The measure of angle ABC would equal 50. Okay? That's an inscribed angle. It's called the inscribed angle theorem, or it's inscribed angle definition, and that is how you find the measure of an inscribed angle. Now, here I have some given information. I have a big circle. I blew it up nice and big so we could focus here. I have a triangle inscribed in the circle. So since the triangle is inscribed in the circle, I have 3 inscribed angles. 60 is an inscribed angle, this guy is an inscribed angle, and this guy is an inscribed angle. I'm going to call these A, B, and C, just so we can name them. All right? Let's start with A. Because I don't know A, but I do know that A goes to C and it goes to B. So the intercepted arc is BC. Oh. Stopped writing. What's going on? We stopped writing. Oh, there we go. BC. See the red? That is my intercepted arc. Why? Because it's B, C, and I want angle A. Okay? So that, here's vertex A. A goes to B, and A goes to C. So if this is angle A right here, okay, what's it hitting? What does angle A hit? The rays of angle A, what does it hit? Okay, it hits BC. So BC is the intercepted arc. It's 140. So angle A must be half of that. So it's going to be 70. Angle A must be 70. Angle B is 60. 70 and 60 is 130. That means this must be 50. So I found they got to add up to 180, right? Three angles of a triangle add up to 180. So I know all the angles of my triangle. Now I want to find this arc. All right, so I'm going to do that. I'm going to leave that actually. I'm going to go green now. I know this is 50. All right, there's 50. And what's my intercepted arc? Here's my intercepted arc for angle C. Here's angle C, and here's my intercepted arc for angle C. Well, if angle C is 50, then the arc is double, because the angle's half the arc, so the arc must be double the angle. So this arc must be 100, and then I'm going to change colors again. I'm going to go to purple. Here is my purple angle B, and that's 60. My intercepted arc is right here. See, AC is my intercepted arc. For this angle, this is 60, so my intercepted arc is double 60, which is 120. Now let's see how that works. Let's prove out why this works. 60 plus 70 plus 50, that adds up to 180, right? Look at what the arcs add up to. 100 plus 140 plus 120, and that adds up to 360. So make sure the arcs add up to 360, and then the angles of the triangle that's inscribed add up to 180, and that's what we know. We already know those things, so that's kind of like a check to make sure we did it right. So the inscribed angle is half of the intercepted arc, or you could say the arc is double the inscribed angle. Now, if I have a semicircle is a half a circle. Well, I know that a circle is 360 degrees total. Whoa, what am I doing here? My circle is 360 degrees total. So a semicircle is going to be 180 degrees, the arc. All right, so here's a diameter, right? And here's the intercepted arc. My intercepted arc, it doesn't tell you, but it's got to be 180. Same thing here. Intercepted arc. Intercepted arc right here. Got to be 180 because it's half of the circle. So if the intercepted arc's 180, the inscribed angle is half of 180, right? Half of 180 is 90, and a 90 is a right angle. So what they're saying is if you have an inscribed angle, see this right here? And it's inscribed to a semicircle. The intercepted arc is a semicircle. Well, if the intercepted arc's 180, half of that's 90, that must be a 90-degree angle right there. Same thing over here. It's a different angle, see? But it's still inscribed. It's inscribed in a semicircle. So therefore it must be 90. The intercepted arc is 180, so therefore the angle must be 90, which is half of the intercepted arc. It's the same. Basically, it comes from the definition on the front page. Here's the inscribed angles theorem, okay? And I use colors, and it's already done for us here. See how, well, I'll read it for you. If two inscribed angles intercept the same arc, then the angles are congruent. How do I know that? Well, here's angle A. It's blue. Here's angle A, and here's angle B. Angle A is an inscribed angle. Angle B is an inscribed angle. Angle A intercepts what arc? It intercepts arc CD. Angle B also intersects CD. Both of these angles intercept the same arc. So it doesn't matter what the measure of the arc is. If it's 100, let's say this arc was 100 degrees, then this angle would be 50, and this angle would be 50. If this was If this was 90 degrees, that arc, then this angle would be 45 and this angle would be 45. The point is, the blue angles, both those blue angles are intercepting the same arc. So we know they're congruent. They are equal. That's all we're saying right here. A must equal B and C must equal D. I could do the same thing on the other side of this circle. I'll do it in red. Here's angle C. Here's angle D. They both intersect. They both intercept arc AB. C goes to A. C goes to B. D goes to A. And D goes to B. They both intersect AB. So if AB were 100, then angle C and angle D would both be 50. If AB were 80, then I know angle C and angle D are both 40. Okay? So it doesn't matter what they are, it's just the fact that they are congruent. C and D are congruent. And that's what this theorem says. It's not giving exact measurements, it's just talking about being congruent. So here's an example, basically what we just did. So if this arc is 70, same picture, if that's 70, then C and D would both be 35 degrees. Just kind of understanding this theorem. And then if this arc was 120, right, then angle A and angle B would both be 60 degrees because they both intercept the same arc. So I hope that's making a little bit of sense, and we'll do a little bit more in class. Last theorem with an example, a couple examples here. It's very important. And this came up on an exam in the past. Inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Okay, so basically, here's the picture. If angle A, or if I know angle A, then I would know angle C. They are supplementary. Angle A and angle C add up to 180. Okay, so angle A plus angle C equals 180. And then I could say angle D plus angle B equals 180. We know that a quadrilateral, the four angles of the quadrilateral add up to 360, but the opposite angles add up to 180. It doesn't have to be a parallelogram or anything. In a parallelogram, we already know they do. But in any quadrilateral, as long as it's inscribed in the circle, the opposite angles add up to 180. So a couple quick examples here. So here's my quadrilateral. It's got all four vertices are on the circle. That's important or it doesn't work. Quadrilateral. Here this is 64, so this is the opposite angle right here. Angle 1 is the opposite of 64. They're not equal, they are supplementary. So angle 1 is going to be 180 minus 64. So angle 1 is going to be 116 degrees. And then this is supposed to say measure of angle 2. All right, and that's the opposite of 58. So 180 minus 58, and that's 122. So measure of angle 2 must be 122 degrees. All right, and then last one here. This is interesting. I know that this central angle, they gave us a central angle. This central angle is 102. So then I know this arc. I know this arc right here is 102. Because the central angle, the angle at the center, is equal to the arc. That's the first thing we said in today's lesson, and we learned it in the last lesson. So if the central angle is 102, the arc is 102, then angle 1, it's inscribed, right? And where does it go? It goes there to there. So the intercepted arc of angle 1 is 102, so angle 1 must be half of that. Half of 102 is 51. So I know that angle 1, I'm just going to get rid of all this. I know that angle 1 is 51 degrees. And now I can do the quadrilateral theorem. See how I have my quadrilateral? Okay? 51 and angle 2 are opposite angles of the quadrilateral. We just learned that they're supplementary, so I'm doing 180 minus 51, and that's going to be 129. So angle 2 is 129. If I draw that quadrilateral kind of on the side here, this was 51. This one had to be 129 because the opposite angles are supplementary if it's inscribed in the circle. I will see you tomorrow for more practice on these theorems and definitions.